In this more advanced exercise, we're going to use regular expression to parse out some important information from large piece of text. These large piece of text come from company earning calls. There's actually a data file called ec10.csv, so it's kind of like a spreadsheet file, stored in the data folder. I'm using a package called CSV to read the CSV file, and I've given you the code to read the file, so I don't need to be concerned about the techniques of reading the files. But basically, I'm going to go over each one of the rows in the CSV file and populate it in a list. So basically, we take a look at this list. This list contains 10 items. Each item is the earning call of one company. So for instance, if you take a look at if you take a look at the first item in data, it's basically the whole transcript of the company earning calls. So if you don't know what an earning call is, it's basically a presentation which is done usually on a quarterly basis, in which the executives of the company gives an update about how the company is doing, future plans, finance, things like that. And they also take questions from the audience. And the whole thing is transcribed verbatim, as you can see. So it's really a large amount of text to read. And we have 10 of these earning calls in this data. So here I just restricted this to the first 1000 characters so that I don't dump the whole thing into my notebook, just to get an idea about what this earning call is about. Now I have 10 of these, and in each 10 of these I want to do the following. First, the company's ticker and the stock exchange symbol are listed in the first few lines in each earning call. Using regular expressions, we want to extract the tickers and the stock exchange for all of the companies. So for instance, this company, Zoe's Kitchen, is listed in the New York Stock Exchange under the ticker Zoe's, is ZOES. And we want to do this for all of them. This is an important text extraction process, which is usually done very often. We would like to really look into these large texts for some important piece of information, such as the stock exchange symbol, the ticker. We also want to exclude tickers of other companies, so we only want to incorporate the first ticker and the first stock exchange listed in each earning call. We're probably interested in what those people are talking about in terms of deals and contracts, things like that. So maybe we want to extract numbers that start with a dollar sign to see, the magnitude of what the financials of these earning calls are about. When we talk about text mining, we will introduce some more advanced techniques to filter, process, summarize text. For now, we will be using regular expressions to extract ticker and stock exchange symbols as well as money from these earning calls. So what I'm going to do first, I'm going to import regular expression package. Now, because I have 10 companies, I'm going to start figuring out the regular expression by playing with the text of one of them. Once I figure out the regular expression, I'm going to apply it on all of them. So that's the strategy I often employ when I have a data processing task in which I'm operating on a bunch of things. To simplify my thought process, I just try to figure it out on one value, and once I figure it out on one value, I can use a comprehension or a loop in order to make it work on the remaining values. So what I'm going to do now, I'm going just to take the first earning call, data 0, assign it to a variable called text. The next step is to try to figure out the syntax of that regular expression. Let's take a look at this earning call here. You can see that the stock market symbol is and the ticker are listed in 2 parentheses, a sequence of character, colon, a sequence of characters. So I'm going to start with these visual cues here. Let's do this. Let's call this stock ticker, compile a regular expression here. Now my regular expression will be the following, just looking at this. Maybe I'm going to start with A to Z, repeated, colon, A to Z, repeated again. So once I do that, I can do stock ticker dot find all text. And notice here that it managed to extract the first one, but it also managed to extract the second one. So I only care about the first one. So I have two options here. Either I only use the 0 because this is it's a list of things. I pick the first one, or I use the other function, the function search. So I can do search here, and the function search will give me a match object, and you can see here the span here, the match object is between 21 and 30. So I can get the match from that. Let's do the match here, which is actually the function called group. And that will give me the first group. So either I do find all and look at the first group, or just use search and do the function group, which will give me the first hit in the text. Now, the next step is to basically figure out the first item and the second item in this match. So I can do this in post-processing, but there is no need to do this extra step. Indeed, I can capture each one of this in a capture group, and hence I'm going to get the result here formatted in a tuple. The only difference in here is that I need to use the function groups rather than the function group, and then I get a tuple, and this tuple contains the stock market symbol as well as the ticker here. Now, if I want to emphasize, to be more specific, I probably can say it starts with a parenthesis and ends with a parenthesis. At least for this earning call is not needed, but maybe for more earning calls it may be needed, I'm not sure. So I just made sure that I include this opening and this closing parenthesis, and thus exclude any sequence of character with semicolons that do not have opening and closing parentheses. Okay, so that's what I have done, and I have figured out how to do it for text. What I'm going to do now, I'm going to make it operate on a bunch of texts here. So I'm going to create a variable called tickers. Let's call it stocks and tickers, because it's going to be the stock and tickers for all of the companies, and I'm going to use a list comprehension. Basically, that's the expression, the function I want to apply, but my text will now vary for each text in data. So let's take a look at the stock tickers here, and you can see here that I've got the 10 stock and tickers for all of the companies here. If I want to separate these into two separate lists, I can do that. I can do stocks equals 2, and then because this is a tuple, what I'm going to do, I'm going to extract the first element in the tuple, so T0 for T in stock tickers, so that's stocks. Okay, stocks tickers, right? And the tickers will be T1. Will be T1, not T0, rather T1. Okay, so I managed to extract the company's tickers and the stock market symbols. Now let's try to extract all numbers that start with a $sign. So we'll start to build this incrementally here. So I'm going to look for, let's call this one money here, to everything that starts with a $sign. And in this case, I would like to get a digit afterwards, repeated. So let's see what that gives us when I process the first piece of text. And you can see I got 40, 41, 54, 41, 54. What does that mean? It's not very meaningful here. Let's print text here and see what these numbers are about. What does $41 mean in this context? you can see it's $31.9 space million. So I obviously missed on the dot here. So, and if I scroll down these numbers, you can see that some of them have dots, some of them actually have commas when you have thousands like this one. So what I'm going to do in this case, I'm going to make this expression a bit more general than what I had before. I'm going to say once you have a dollar sign, you will start with a digit, but then once you start with a digit repeated, you will also have more things to say. It can be a dot, it can be a comma, it can be another digit space. Maybe repeated 0 or more times, maybe repeated 1 or more time, and that will capture, as you can see, more aspect of that number. Now that doesn't still capture the character itself, right? So it doesn't capture what 54.5 captures here. Now again, in this case, we need to make the regular expression general more. So what I'm going to do here, I'm going to allow a white space here, maybe \s, and another character repeated just to capture that million things or the qualified aspect of the number here. So once again, you can see that sometimes it captures something important, such as 41 million. Sometimes it captures something which is not very important, such as of or related or compared. So we can actually make this a capture group. We can say, okay, well, the number here is important, obviously. So let's capture it. And maybe the qualification of the number is important too, so that we can examine the qualification here, the number and its qualification. And we need to figure out which one of them is important and which one is not important. Once again, this is a limitation of the regular expression. It's just a pattern of text. When we get into more advanced techniques in text mining, we will see a better way to extract numbers than using regular expressions. Now to finalize, don't forget that this is only applying it on one earning call. We still need to do it on all of them. So what I'm going to do now, I'm going to take that earning call here, I'm going to take the expression here, and I am going to apply it on all of the earning calls. So let's call this one money extract. Is going to be this thing, well, the thing that I deleted actually, money.find all text for text in data, and that basically will give me a list of lists. Each list is basically the extract of a company. This is the first company, this is the second company, and this is the third company, and so on and so forth. So you can see here the money being discussed in each one of these companies, in each one of the earning calls. Finally, we usually want to save this information to a text file. So this is something we will take a look in the future. Many often the purpose of doing, operating in the notebook is to be able to read the data and then at the end write it to an output file such as a spreadsheet. We will see an example of this, but the notebook environment itself is not very conducive to exploring large amount of data, meaning manually looking for the output of the process itself.